Sure. So I'll start. Yeah, sorry for the delay. So basically this week we'll be discussing about malloc lab debugging. So it's due towards the end of the week. So basically it's due on Friday, and we do see that not many people have submitted. So we'd really encourage you to start off early so that you have enough time to finish this up. And if you're stuck somewhere, just make sure that you spend enough time understanding why it's failing and what's happening before you can reach back to us. And yeah, it's very difficult, as you know, for us to really debug, sit with you and understand what is the error or what is the difficulty that you're facing. So in terms of errors that you'll see, fortunately some of the errors are given by the driver itself. Things like you'll notice that there are error in traces where it says you have 1 byte, garbled byte, etc. Now the first few errors that you will notice is mostly because you are already allocating a pre-allocated data. So the driver is capable of detecting that and then showing that as error to you. So that's the essence of the first one. And the others are in terms of alignment. So some of these errors are automatically detected by the driver that's given to you. So some of these are very helpful for you to debug and understand where you're going wrong, but not a lot of it is always available. Most often you'll see something like just segmentation fault. So these are probably the hardest ones to debug because you don't know where to proceed from. So one of the simplest ways that you could really debug is using GDB. I mean, I do understand that a lot of times when you run multiple cycles you encounter this particular issue, but often you'll notice that if you do see an error at say the 50th or 60th iteration, it's probably that you're going wrong in one of the first few initial iterations, because things will cascade and ultimately fault if it cannot handle at that point. So ideally GDB will be really helpful, especially to go over the initial iterations of your design, because you can clearly verify whether you're doing it right up till that point of time. And yeah, seg faults are pretty difficult to debug, and one of the simple things that you could do is try printing the whole heap down, but often that ends up accumulating so huge that it becomes difficult for you to actually figure out what's happening and where it's going wrong. So the best other way that we see is using the heap checker, and this is one of the reasons that we've been asking you to really concentrate on heap checker and make sure that this is very firm and can detect some of the basic errors that you normally encounter. So last time we did discuss about some of the common things that you can put it in heap checker, so we'll just go over that a little more again. So heap checker is basically used to check for different invariants of your code in terms of whether you have the strict alignment in place, whether you have the header footer in place and things like that. So it's possible that say when you encounter a seg fault, you could define, you could have a debug print such as this to say that where you can put it in multiple lines of your code and check whether the heap at this point in time is really valid. So if you have this in place and you keep checking it multiple times, it'll really help you to figure out whether you're going wrong anywhere or not. So all that you'll have to do later on is just hash define debug, or just comment this out, and then you'll have this check go away, and you'll really see the correct values in terms of utilization and performance. But this is very useful in debugging, especially if you write the check heap correctly. And I mean, we've been telling this to everyone, so again, I'd just like to repeat that make sure you do have the heap checker in place, because this is really going to help you. And what are the invariants, or what are the things that you can basically check? So you can divide it based on block level, list level and heap level. Block level is basically make sure the header footer matches and the payload is aligned. So we would want it to be aligned to 8 bytes, so you can ensure that this is in place, and based on whether you have a header footer and what's the minimum size required, all that things can be checked there. In terms of list levels, since once you move to explicit list and segregated list, you'll have see the presence of next and the previous pointers. So some of the things is you can check for whether you're actually pointing to a correct free block. So things like that can also be checked, and all the things with respect to traversals of the free list using the next and the previous pointers can be checked. And in terms of have you handled coalescing of the blocks that are next to each other in the virtual memory, things like that can also be checked. And when you move to the heap level, things like the presence of the prologue, epilogue, and do you have the heap boundaries in place, and are you checking for all that? So other things that you could do is based on your implementation of segregated list. If you have something like an address ordering, or say that can be checked here, and say if you have buckets which are of different sizes, so that can be one of the things that you can check. So I'm in this particular list in my free list implementation. So if you have a free list, let's say these are the starting addresses and you have a free list here, you can make sure that each of these, if this is bucket 0, this is bucket 1, you can ensure that if you say my bucket 0 includes all size, say between 0 to 50, for example, in terms of bytes. So you could use the heap checker to actually figure out, is all the memory regions in this particular bucket is lie within this range. Similarly, you could have checks for multiple buckets that you maintain. So that can be one of the things that you can add. So make sure that this is thorough so that it's very useful for you in debugging. And as we spoke last time, some of the simple things that you can figure out if you have a loop in your list is using the hare and the tortoise algorithm. So the basic idea being you maintain 2 pointers, where one of the pointers here, the tortoise moves just one node in the free list, whereas the hare moves across 2 nodes in the list. So if this happens, when you see hare and the tortoise again pointing to the same node, you basically encounter a loop in your list. So this is one of the simple things that you can use to test your code. Now, other things that you'll need to make sure is to have the init clearly initializing everything. So if you have a head node pointer which points to the first element in your list, things like that have to be initialized there. So you'll need to take care of the initialization part in init very correctly, and that will really make sure that the rest of the code falls in place. So the heap checker again is the most critical thing. So make sure that you have that in place and often keep calling it, especially when you encounter things like segmentation fault. Now, some of the tools that can be used, as we spoke of, was valgrind. So valgrind is very useful, especially if you're leaking memory. So although you may see your code run correctly, but often you'll end up asking for more memory. So some of the things that could happen in that case is you are basically not taking care of the free blocks that are there, and probably not freeing it correctly as well. So you can use valgrind there to figure out how much of memory are you using, and is there any leakage of memory, and valgrind will be able to point that out to you. And the other thing is GDB. You can use watch points to basically keep track. Say for example, if your header, the head pointer is going wrong, so if that pointer is going wrong, you can keep a watch on this particular variable to see how it changes and what is changing there. So this will again be helpful in the initial debugging phase. And in terms of asking for help, what we would highly recommend to you is to make sure that you clearly understand where it's going wrong. Just coming to us saying that there's a segmentation fault would make it hard for us to debug as well, because primarily this is an open-ended lab. So you have many ways to do it, and there's no better person who understands the code than you. So you should be able to answer some of the basic question in terms of, if I execute this particular line and say this particular iterations of the code, it's failing. So if you come with some details like that, it'll be very easy for us to give you suggestions, and we could probably sit together and debug that particular issue. So it's pretty much expected from your end to really understand what is the error or what is the issue that is happening. And if you don't get enough answer, if you can come with us with as much as data or information as possible, then it will really be helpful, and we could help resolve the issue much faster. And again, reiterating the fact that make sure your heap checker is used, because that will very easily be able to detect some of the errors that you have. And in terms of, we basically need a summary, and if there is summary, we'll be able to easily debug. And you could come to us at any of the office hours that we have in the evenings from Saturday to Thursday. So we'd be happy to help at this point in time. And in terms of error prevention, so it's very hard to really code everything to completeness and make sure it works fine. So we'd recommend you to go step by step. So start with the implicit list, make sure that it's working full thorough, just have a check of that, implement heap checker there, make sure you check it through heap checker as well and see the whole thing is working fine. After that, move to explicit, again ensure that it works thoroughly. Once you have all that in place, then move to segregated list. So moving from explicit to segregated is not too hard, because it's just an, instead of having a single bucket, you're just going to have multiple buckets in there. So it's not too much of a change, but yes, there are issues with respect to debugging and with respect to tweaking the code in terms of getting the right performance. So we'd encourage you to go step by step to make sure you have the checks in place and you ensure the previous stages have all been working fine before you move to the next one. And essentially for each of these phases, we'd recommend you to write a pseudocode at the start to ensure that you have the understanding correct and you believe that it's going to happen fine. And then since all of these operations are basically dealing with pointers, it's often very difficult to understand the code even for ourselves. So when we write a code, it's often difficult primarily because you're dealing with certain set of macros. So you'll often write something like get and head p, and there'll be a list of macros, and ultimately this is what you'll be using it in your code. So it's often very difficult to understand what each of these does until and unless you have some sort of a documentation or a code comment that is in place. So they encourage you to write a lot of comments in your code so that it's easy for you to understand, and when we do evaluate your code, it's easy for us to understand as well. And so another thing is the version control, because it's often possible that a small change in your code could really lead you from, say, even having 95 to 0. Primarily being because there is some minute change and it's often very difficult to understand what was the change and why it happened. So we'd really encourage you to have a backup of each stage of your program. So keep a backup and then work on the old code. One of the simplest ways to do that is using the cp command, the copy command, where you copy this current version of the code somewhere and then use the existing code to modify it. The other things that you could do is use git, cvs and svn. I'd highly encourage you to use git, because future on any projects that you work on will be much bigger than this. You would not just modify one single file. So it's often very difficult to keep track of all of those. So getting to understand use git now will be very helpful future on, because this is one of the things that most people tend to use. Even enterprise like companies often end up using git. So we'd highly encourage you to start using git right away. And in terms of optimization, it is not sufficient to just have multiple buckets and have the chunk size that is in place. It's often better that you start tweaking those parameters as well, because all of this will affect the overall performance. So make sure you have enough time to actually play around with this and understand how it affects your code in terms of what is the given trace files. So have a look at this as well and do try to play around with that. And a lot of these code is essentially using macros, and we'd expect you to have it as modular as possible. There are some functions that are already given to you, like place, coalesce, etc. So make sure that when you have buckets and things in place, you have separate functions that deal with the specific functionality that you're looking for, so that it's often easy for you to debug as well and easy for us to understand when we evaluate your code. And the other thing that you might see is you might be doing well in utilization, but the performance may be bad. So for things like that, a good profiling tool will be useful. So some of the things that you could use is like the gprof. So make sure you had the -pg parameter in your makefile while compilation. And when you run this, you can just run gprof mkdriver and to see the results of what is the evaluation of the profiled results. So, and make sure that you change it back with you remove the -pg back when you actually finally run and get the results, because hiding profiling will essentially reduce your overall performance, because it's going to print out some certain logs for you. So finally, when you do submit, make sure that you remove the -pg flag. And in terms of the fine words, basically if you haven't started now, we'd highly encourage you to start, because this is not that easy a lab. And yeah, heap checker again. So make sure that you have written it well so that it's easy for you to debug. And in terms of like, be prepared to start over several times. Often this happens that you approach it in a certain way and then you don't really get correctness. So make sure that you have a backed up version where you can start back from and make sure you proceed from there. This can happen often in this case. And make sure you have enough comments in your code so that, again, it's easy for us to understand. And make sure you follow the coding guidelines that has been specified. Things like not many, there shouldn't be no line any more than 80 characters. I mean, it's often that we skip all this. So if you're using any editors, there are often simple methods to figure out, are you actually exceeding 80 characters? So you could probably incorporate this in your, say, Vim or Emacs or different tools that you use, and they'd be able to easily detect if you're going beyond 80 characters. So that'll really be helpful for you. And ultimately, yeah, basically good luck. Make sure you spend enough time on it, because it's really possible for you to get a high score in this lab. And this lab is the basic sort of introduction to pointers, and if you're able to do this well, it clearly shows that you've understood pointers and how to manipulate pointers really well. So that's essentially the recitation for today. So if you have any questions, I'd be happy to answer. All right.